In this video on arithmetic sequences, we'll cover lesson goals. I'll hop over to Cognity, our reading, and I'll provide some commentary to help us better make sense of the material. And then I'll cover 2 additional problems that aren't in your reading that I think will help supplement what we're learning about. So, our lesson goals for today. Go ahead and pause this video and take a quick read through the lesson goals. All right, so what we're going to do is in Cognity, I'm not going to read everything to you. I'm not going to go over every concept and every example because you've already done the reading. But I do want to supplement it with just a few key things. For sequences, let's just go over how to say these terms in case you're not familiar. This subscript, we always say it's U sub 1, U sub 2. And that represents the first term of a sequence, or the second term, U sub 1, U sub 2, U sub 3, all the way up until U sub n minus 1, U sub n plus 1. And next, what I want to cover is in arithmetic sequences. Some things that you'll have to do is you'll have to justify why something is an arithmetic sequence. And if you want to show that something is an arithmetic sequence, you want to show that they have a common difference between each of the terms. So in my mind, I'm picturing this like little arc that's going, minus 2, minus 2, minus 2. And here we found that the difference between all the consecutive terms was constant. They were all minus 2. And that's the reason why we have a arithmetic sequence. All right, next what I want to cover is translating arithmetic sequences to formulas. So we have a few formulas that we want to have memorized for arithmetic sequences. And this is essential knowledge you have to know about arithmetic sequences. So the first is the common difference formula, and that's just the common difference is a term minus whatever term comes before it. That's u sub n minus u sub n minus 1. We also have the deductive formula, or the general term formula, and that's u sub n is u sub 1 plus n minus 1 times d. And that's where n, or this number right here, or which term we're talking about, like the first, second, or third term, that's an element of the positive integers. So if you're not familiar with this notation, this little E-looking thing, it's kind of like a C, but with a little line making an E, that means an element of. And then this integer, the way that we write that is we write a big Z and we make it look bold by putting another line there, and it's always good practice to do horizontal lines with your Z. And this is positive integers, which means that it's only like 1 through infinity, no zeros and no negatives. So that's just some notation for you. We also want to know the recursive formula for arithmetic sequences. That's where a term is the term before it plus the common difference, okay? And that's going to be important for these more algebraic problems where we are writing down an expression for u sub 2, u sub 3, and u sub 4 in terms of u sub 1 and d. So we see this phrase in terms of. This is really important because in terms of means that your final answer down here can only have u sub 1 and d in it. Now, this n, it doesn't really count because it's not considered a variable in our formula because it's just which place you are in the sequence. But you'll notice that we don't have any u sub 2s or u sub 3s or anything like that. So in terms of, your goal in your mind means that only u sub 1s and d's are allowed, okay? And this we really just use formulas at this point. When we have our formula for a recursive, namely that here u sub 2 is the term before it, u sub 1 plus d, and we have u sub 3 equals u sub 2 plus d, well, that u sub 2, we have a substitution. U sub 1 plus d, that's u sub 2. So where we see a u sub 2, we put a u sub 1 plus d back in there. And then we start to use this pattern over and over again, where we have u sub 1 plus d, u sub 1 plus 2 more d's, u sub 1 plus 3 of those d's. And you'll notice that this 3 right here, this 3 right here is just 1 less than n. And so if you follow that pattern of there's a 2 here and only 1 d there, there's a 3 here, there's 2 d's there, there's a 4 here, there's 3 d's there, that is n minus 1. That's where this formula comes from. But I wanted to really go over this example with you because there aren't any numeric terms in the sequence. They're just variables. And so when we have that, we really want to go back to these formulas and ask ourselves, which one of these makes sense to maybe try to wrestle with for this problem? I think that's all I wanted to cover for the cognity. And next, I want to show you two examples that are similar to ones that you did read about and you're practicing with, but I think it's useful for me to just kind of go over my take on how to tackle some of these. So let's problem solve. It says that the second term of an arithmetic sequence is 13 and the fourth term is 7. What is the 13th term? So right away, it doesn't really even seem like we need algebra for this. I mean, if you just think like, okay, well, let me start labeling this. The U2 is 13. The fourth term, that's a U sub 4, is 7. I mean, a lot of people don't even really think about this using algebra. They sort of just think like, okay, well, I've got 13. I've got 7. And how do I get from one term to the next? It's like, well, what's in the middle of those two? Well, yeah, I mean, it's 10. So like right away, you're thinking subtract 3. And just using that logic, you can go backwards to any of these terms. And it's like, well, if you just keep counting, you could get to the 13th term pretty easily. And that is totally fine. Nothing wrong with that approach for this particular problem. This one is easy enough where you can just hard code this. You can just figure it out by counting a bunch of times, using counting principles. However, once we do expand this to algebraic, or if it said like the millionth term and you didn't feel like counting that much, or maybe you didn't want to use your calculator, we do want to understand how to represent this algebraically. So we want to ask ourselves, which one of these three formulas maybe makes sense to use in this problem? Well, it's not going to be the recursive formula because we would have to know terms that are right before other terms. And we figure that out in this problem, but in general, we won't necessarily know that because these numbers were easy enough to figure out on our own, but in general, we won't know. So maybe let's try using the deductive formula. So let's try using that U sub n is U sub 1 plus n minus 1 times d. And let's see what we have here and what we don't have. We weren't supposed to know what U sub 1 was. So we're not supposed to know that. So we don't actually know that, even though we figured it out. N minus 1 and d, we didn't know the common difference before, so we can't assume that. But we do have specific cases of U sub n. For instance, U sub 2, which is really 13. 13 equals U sub 1 we don't know. This is plus. And then we know what n is. N is 2 for this case. So we're going to have 2 minus 1 times d. All right. And let's also write the formula, but using U sub 4, which is 7. 7 is U sub 1 plus, and then this is U sub 4. So that's going to be a 4 minus 1 d. I'm just going to clean this up a little bit. We have a 3, so 7 equals U sub 1 plus 3d. And then on the other side, we have 13 equals U sub 1 plus 1d. All right, and now let's think about this. We have a U sub 1 in both equations and a d in both equations. This is our classic systems of equations with two of the same variables. So I'm going to put them one on top of another, and I'm just noticing right away that we can use elimination, the process of elimination. And the elimination is when you have two equations that have the same two variables, you can subtract both of those equations from one another. We have 13 minus 7 is 6 equals U sub 1 and U sub 1 cancels, U sub 1 minus U sub 1. And then d minus 3d is 2d. Negative 2d. So we just divide over and we get right away that d is negative 3. So we'll go ahead and have equals negative 3. Oh, let me handwrite that. Equals negative 3. All right, so now that we have d is negative 3, it says, what is the 13th term? And actually, I really probably shouldn't have boxed this because this is not my final answer. We want to make sure we're actually answering the question here. So we use that d equals 3 to find u sub 13. So this implies that. All that work implies that. That's what the arrow means. We want to know u sub 13. Well, we have a formula for that right here. U sub 1 plus 13 minus 1, which is 12. The common difference is 3. All right, and at this point, yes, we do have that 16. And because we found the common difference, we can assume that we can work backwards from u sub 2 at that point. So that's okay. So u sub 13 is 16 minus 36. Then we have 16 minus 36 is going to be equal to negative 20. Okay. All right, so we got negative 20. We are good to move on. Let's look at one final example. We have the first 3 terms of an arithmetic sequence, and we have a u sub 1, 3k minus 1, a u sub 2, 4k plus 1, and a u sub 3, 6k minus 2. And we want to know, what is the value of k? This one, we really can't do this in our head just by counting, just figuring it out, just like we did in the previous problem. So we maybe do want to really just go ahead and rely on some formulas that will help us make sense of this problem. So let's think. I have u sub 1, u sub 2, and u sub 3. I don't know what the common difference is, but if I did, it would be the same. So I do have I have d's running around. I've got the first 3 terms. So let's see. So we do have u sub n and a u sub n minus 1 in the recursive formula. So that could help because we do have consecutive terms. So let's see what we can do with that. So let's use the recursive. Let's use u sub n is u sub n minus 1 minus d. So let's choose something like a u sub 2 and u sub 1 because those are consecutive terms. That would be 4k plus 1 equals 3k minus 1 minus d. All right, I'm going to subtract the 3k over, add the 1 over. We'll get k plus 2 equals negative d. All right. Well, now I've got 2 variables. However, I do have my u2 and my u3, so I'm going to do this again on the other side. So we have 6k minus 2 equals 4k plus 1 minus d. All right, so that's the u sub 3 equals the u sub 2 minus d. And then I'll use some algebra to solve this too. So that'll be 2k, subtract the 1 over, minus 3 equals minus d. Okay, so, here's something that looks interesting here. I have negative d equals something, and another negative d equals something. So those are equivalent expressions. So because of that, what these negative d's are equal to each other. That's actually the transitive property. So we have k plus 2 equals 2k minus 3. Subtract the k over, add the 3 over, and we get that k equals 5. All right, so that is a case where we really do want to ask ourselves which one of our 3 formulas we know about arithmetic sequences can bring all this together. There are other ways you could have solved this problem too, but this is one additional way to have in your arsenal. All right, folks, let me know if you have any questions in class.